Hello guys, welcome back to Maison African Motives, still on engineering science N3, working in this case on motion, power, and energy from the question paper of November 2020. We are given the first part of the question, which is question 1.1. Let's quickly rush through the questions. We are given what is meant by the speed of an object. Okay, so if we are referring to speed, remember that speed is actually equivalent to the distance over the total time taken. So this is distance over time. So if we can define this as speed is equivalent to distance over time, that means we can simply define as the rate of change of distance. So this is the rate of change of distance, or measured in meters per second. So this is measured in meters per second. All right. On 1.2, we are given that a car accelerated uniformly from 15 kilometers per hour to 72 kilometers per hour. The distance covered during the acceleration is 250 meters. Calculate the average velocity, the acceleration, the total time taken. Okay, so here we can have our diagram, or we can just use the formulas for linear motion in this case. So we've got our initial velocity, which is 15 kilometers per hour, and final velocity at 72 kilometers per hour. All right, so this is 1.2. So our U in this case, it was 15 kilometers per hour. So you can convert this to meters per second. Remember, to meters per second, we divide by 3.6, since 1 meter per second is equivalent to 3.6 kilometers per hour. So we can just divide by 3.6. So 15 divided by 3.6 is going to give us something like 4.167 meters per second. And our final velocity was at 72 kilometers per hour. So if you do the same, 72 divided by 3.6, that will be 20 meters per second. All right, and we are also given in this case the total distance, which is in this duration, the duration for the acceleration, which is 250 meters. So you've got 250 meters in this case. All right, so from the information that we have, take note, guys, this is for linear motion. So the first part of the question we are given in this case to calculate the average velocity. So the average velocity can be taken from U plus V over 2. That is the average for the given velocities. So you add the initial to the final velocity divided by 2. Remember, it's required in meters per second. So you use the 1 in meters per second, or you can use kilometers per hour, then you convert to meters per second. All right, so that is our U in this case, 4.167 plus V, which is 20, everything over 2. So make sure that you apply your calculator properly. In this case, you're going to obtain something like 12.084, which is measured in meters per second. So that is our average velocity in this case. So it's very, very important, guys, that you understand your formulas. Okay, the other part, we are given to calculate now the acceleration. Okay, during this period, what is the acceleration? So from our formulas for linear motion, let's check which formula is best to use. We have got, in this case, U, V, and S. So remember that from our linear motion, that's 1.22. We have got these formulas, that is V is equal to U plus 80, but we can't use this formula because we do not have even T in this case, all right? We also have a V squared, which is U squared plus 2AS, which can be best to use in this case because we've got S, we need A, we've got U and V. Okay, so we're going to take this formula. All right, so since V squared is equivalent to U squared plus 2AS, we can make A the subject because we need acceleration in this case. So take note, we must supposed to calculate acceleration. So to find A, we can transpose U squared to the other side, which is going to be V squared minus U squared is equal to 2AS. So to find A, we can divide by 2s, 2 here and s. If we divide, that can actually make A the subject. So divide by 2s both sides, by 2s both sides. This can cancel. We remain with A. So A is equivalent to V squared minus U squared over 2s. So if this is the value, or this is the expression representing the value of A, therefore, we are going to substitute our information. A is equal to V. In this case, in meters per second, our V is 20 meters. So this is going to be 20 squared minus U squared, which is our initial velocity of 4,167. So we are going to have 4,167 squared. Everything over 2 times S, which is our S in this case, is 250. All right, so that is what you're going to have from your calculator. Make sure that you simplify properly. You are going to obtain 0.765 to 3 decimal places. That is your acceleration in meters per square second, or you can even write this as meters per square second. In this way, it's still one in the same way, or it's one in the same presentation that you're given. All right, so that's what we had from this question, 1.22. On 1.23, the time taken, okay, we need the value of t. All right, so let's get back here. We have got A. I remember from this formula that I first presented before, 1.23, we need the time this time, okay? So remember from this formula here, we talked about this formula before, that we have got V, which is equal to U plus AT, and we've got T in this case. So you can play around with this formula. Since V is equivalent to U plus AT, we can just substitute our values, then make T the sub, and then calculate T, or you can make T the subject. As for me, I prefer making the letter to be calculated the subject, then substitute values from there. Okay, so I'm going to transpose U to this side, which is going to be V minus U is equal to AT. Remember, I want to calculate the value of T, so I'm going to divide by A since it is multiplying. So here, this can cancel. That means we are going to have this as T is equivalent to V minus U over A. All right, so that's what you're going to have in this case. So from this formula, T is equivalent to V minus U. So remember that our V was 20 meters per second here. That's our V. Then our U, 4,167. So we've got 20 minus 4,167. Everything over A, which is the acceleration that we got here. Remember, we obtained our acceleration, which is 0.765. So that means we can have our time in seconds. That will be 20,697 in seconds. So that's how you can simply have this information. So it's very, very important. If you're working with motion, guys, it's all about the formulas. List down your formulas. Then from there, you have to pick the right formula according to the information that you are given. All right, so let's check the other part of the question, which is on 1.3. So on 1.3, you've got an information that is affecting a momentum. Okay, so we've got a ball with a mass of 50 grams moves at 5 meters per second and collides with a ball with a mass of 80 grams moving at 3 meters per second in the opposite direction. After collision, the first ball maintains its direction and moves at 2 meters per second. Calculate the velocity of the second ball. All right, so this is what is happening, guys. We've got 2 balls in this case. They are moving in opposite direction according to the information that you are given. So I'm going to take the first ball moving to the right. Okay, so let's say this is my first ball moving to the right, and then the second ball moving to the other direction, which is opposing. So this is going to carry a negative since it is opposing. Okay, so each ball that we are given its mass. Okay, so for the first ball in this case, this is our second ball. From the first ball, we are given that it has a mass of 50 grams and moves at 5 meters per second. So here we've got the mass of 50 grams. That is our M1, which is 50 grams, and it is moving at a velocity of 5 meters per second. Okay, let's check about the one that is opposing, which is the ball 2. The one that opposes, it has got 80 grams moving at 3 meters per second and in the opposite direction. So this is 80 grams. Okay, so this is our initial velocity for the first ball here. Let me just write so that we do not confuse. So I'm going to just write this as U1. Okay, here we've got the mass of the second ball, which is given as 80 grams, and also the initial velocity of this ball, which is the second ball, which is 3 meters per second, but it is opposing, so it is going to carry a negative, so that's negative 3 meters per second. All right, so this is what you're going to have in this case. After collision, these balls, they collided and so forth, then we are just given that the first ball, when it is moving after the collision part, we are given that the first ball is moving at a velocity, okay? We are given its final velocity. Here, after collision, the first ball maintains its direction and moves at 2 meters per second, which means we are still, if it was going to the right like this, it is going to maintain the same way to the right, okay? This is what we have. And its velocity now is at 2 meters per second. So this is our final velocity, which is 2 meters per second. So we know that after collisions, definitely the mass of the first ball is not going to change. So it is going to still remain with its mass of 50 grams. Also, even the second ball is not going to even change. It's going to remain with its mass of what? Of 80 grams. Okay, so depending with how you want to use these values, someone can convert these to kgs, okay? Remember that your mass in kgs, if you convert this, divide by 1,000, that will be 0.05 kgs. So this is 0.05 kgs. This will be 0.08 kgs. So you say this is 0.05 kgs. Okay. Then for the second ball, we do not know what is going to happen for this second ball, but what we know is that its mass is not going to change. It is going to remain at 0.08 kgs, but we do not know its final. This is the second ball, so it's M2. Then its final velocity is the one that we do not know, and its direction. So how are we going to find this? Remember from our momentum concept that the initial value for the total is the same as the output or the final. So remember, mass times velocity gives us momentum. So you're going to have M1 by U1, which is the initial velocity, plus M2, which is the second ball, its mass and its velocity. So this is for the initial consideration. Then after collision, you must obtain the same thing. So after collision, now we are talking about M1 times the final velocity. The mass does not change, but the velocity has changed with now final velocity. So we've got M1 V1 plus M2 is not going to change its mass. The mass does not change. Only what has changed is the velocity, which is V2. So we're going to substitute the information that we are given so that we can have the value for V2. Remember, V2 is the unknown value that we are calculating. Everything we have. M1, we say this is 0, according to the kgs. If you want to use this in kgs, this will be 0.05. Actually, that is for us not to have any confusion, okay? So that's 0.05 times U1, which is the initial velocity of 5, plus M2, which is for the second one, that's 0.08 in kgs. So we've got 0.08 in kgs times U2, which is the initial velocity. It is a -3. Remember, it's opposing. That's why it has to carry a negative. So that's -3, which is equal to M1. The mass does not change, still at 0.05 kgs, times the velocity now, which is the final velocity. So remember, we say this is for initial conditions. This is for final conditions. So we use the final velocity at 2 meters per second. Remember, we are told it maintains its direction, which means it's still a positive, just like the first consideration, plus M2, which is 0.08 times V2, which is the one that we need. Okay, so we are going to calculate V2. And from calculating V2, we are going to know even its direction, okay, from the sign that you're going to obtain. So here we are going to obtain, if you simplify properly, that's 0.25 minus 0.24. So if we multiply these two, we are going to obtain 0.1. Then we transpose to the left side, that will be a minus 0.1 is equal to, this is 0.08 times V2, which is just 0.08 V2. So to find the value of V2, we can combine everything on the left-hand side, which is going to give us negative 0.09 is equal to 0.08 V2. So to find V2, we can divide, since we are multiplying, we can divide by 0.08. All right, so that's, we have our V2, which is the final velocity of the second ball. So if we divide properly, this will give us negative 1.25 meters per second. So what does it mean? It means the velocity actually it's at 1.125 meters per second in the opposite direction. So if this was, if the first ball was moving to the right, that means the second ball is moving to the what? To the left. So that is what you're going to have, or in the opposite direction. Since the first ball is having a positive, this will be in the opposite direction. That's a negative. Okay, so that's what we had. Simply like that. It's an application of formulas, as you can see. That's how you can apply your formulas to attempt these typical questions. All right, on 1.4, we are now given a pulley with a diameter. All right, we are given a diameter in this case of 40 centimeters, is driven at 8 revs per second. With a diameter of, so take note here, guys, we've got two things. It's driven. So this is a driven pulley in this case. So we've got the driven and the driver in this case. Okay, so let's just write this properly. So we have got the driven and the driver. Okay, so we've got the driven, and here we've got our driver pulley. Okay, so on the driven part, I'm just going to write this in terms of, so that we do not confuse, I'm just going to write in terms of G. And on the driver, I'm just going to write in terms of small letter d like that, so that we do not confuse. Like you can use the capital letter D and small letter d for diameter, so that you don't confuse, but it's one the same thing. Okay, so we're given that a pulley with 40 centimeters diameter is driven. So which means we're talking about the driven. In this case, we've got the diameter, but I said I'm going to use a G. So this is DG is equivalent to 40 centimeters. All right. So remember, in meters, 1 meter is 100 centimeters. So if you divide by 100, this will be 0.4 meters. And its speed is at 8 revs per second. So you're given the speed, which is at 8 revs per second. All right. With a diameter, so now it's by a belt from a pulley. So it is driven by, which means now we are talking about the driver now. The one that is driving has got a diameter of 0.6. So remember, I said I'm going to use the small letter d for driver. So d like this for the driver is going to be 0.6 meters. The tensile forces in the tight belt are 500 Newton and 200 Newton respectively. So how do you know this is T1 and T2? Remember, T1 is for the tight side, and the tight side is supposed to have the bigger force. So we are given T1 and T2 in this case. All right, so we are given T1 and T2. So we are given that T1 is equivalent to 500 Newton, which is the bigger force. Then T2, which is the slack side, it has got lesser force, which is a 200 Newton respectively. Okay, so this is the information that we have for now. Okay, so the first part of the question is to calculate the following: the rotational frequency of the driver pulley. So we need here the rotational frequency for the driver pulley. We do not know. Okay, so how are we going to have this? Remember, from our ratio concept, the ratio of diameters and so forth, we understand that this is 1.41. The product of the diameter for the driven to the number of rotational symmetry, which is the rotational symmetry in this case for the driver, is equivalent also to the diameter for the driven times the number which is the rotational number of symmetry, or the rotational frequency, sorry, the rotational frequency of the driver in this case, which is ng. So if this is in revs per minute, this must be also in revs per minute. If this is in revs per second, this must be also in revs per second. So we are given in revs per second, which means our ND is supposed to be also in revs per second. So we can calculate ND in this case by dividing this by D, the diameter of the driver. The diameter of the driver in this case, that's we can have our ND. So that means the rotational speed of the driver is equivalent to the diameter for the driven, which is the diameter of the driven in this case, which is 0.4 times the rotational speed for the driven, which is 8 over the diameter on the driver of 0.6. So we are going to have this as, okay, so let's simplify. So that means we are going to obtain something like 5,333 and so on. So this is in revs per second, 5,3333 and so on in revs per second. Okay, so let's say you want to convert to revs per minute, because here we are not told to give your answer in revs per second or revs per minute. Okay, so if you want to convert to revs per minute, you multiply by 60. Remember, this is per second. So that means in revs per minute, if you multiply by 60, this is going to be 320 revs per minute. So you can leave your answer in revs per minute or in revs per second. All right, so that was what we had on 1.41 in this case. Okay, let's check the other part of the question, which is 1.42, the velocity ratio. Okay, so for the velocity ratio, we can use a lot of formulas. Okay, so here, depending with the information that you are given, remember, we can say the velocity ratio is equivalent to the driver over the driven. So we can use the speed on the driver over the speed of the driven, or we can use the diameter. But take note, when we are dealing with the diameter, is diameter of the driven over the diameter of the driver. Okay, so this is driven, this is the driver. If you, that is what you could that is what you could use in this case. So I'm just going to work with the diameter. Since, guys, take note, we already have diameters here. All right, we already have the diameters. These are the diameters. The speed that we have, we calculated this speed. So if anything is wrong, that means it's going to even affect our answers. So in order for you to avoid such things, use the values that you're already given. So already you are given the diameters. Okay, so it's best for you to use what you are given already, so that you know that the chances of you making mistakes, they're very, very low. All right, so the diameter on the driven, which is 0.4, divided to the diameter of the driver, which is 0.6. This is going to give us 2/3 or 2s⁻3. So that's 2/3 or 2s⁻3 as our velocity ratio. All right. Then we have got the belt speed, which is v. So v can be taken from any information depending with where you have full information, because we understand that v is equivalent to, that's 1.43. So v is equivalent to pi dn. All right, so like I said, it depends. Okay, so if you use this as n, that will be in revs per minute over 60, but let's use this directly so that we do not confuse, as n, small letter n, representing the revs per second. So this is the diameter. So like I said, it's going to depend with the information that you have. If you are working with the driver, okay, let's say you are working with the driver, that means your V is going to be pi d for the driver, then N for the driver. If you are working with the driven in this case, which means your V is going to be pi, then we've got D for the driven, then N for this is just whatever that you're given, but make sure that your N is in revs per second. Okay, so I'm going to use the one that we already given. Remember, we calculated for the driver. Okay, we calculated this, but before we are already given for the what? For the driven, this information is already, it's best for you to use the information that you're already given than to use the one that you calculated by yourself. If there is an error there, it's going to affect your final answer, but I'm saying you can even use any of these, okay? Because our ND, we have it here, but make sure it's in revs per second if you are to use this one. If you use revs per minute, therefore divide by 60. Okay, so I'm going to use the one that we are already given, which is for the driven. So that means our V is going to be pi d for the driven times the N for the driven, which is the rotational speed. So that is pi times d for the driven. Let's check here for the driven, our d is 0.4. Then our ng, which is the speed, is 8 revs per second. So this is times 0.4 times 8. So that's 0.4 times 8. All right, so this is going to give us the velocity in meters per second, which is going to be 10,053 if we round off to 3 decimal places in meters per second. All right, so that's it. Like I said, we can even work it from the driver. Still, it's one and the same thing. You just pick your information depending with the information that is best for you guys. Is it for the driver or for the driven? All right, so that's what we had on this question, which marks it a total of 16 marks on question number 1. So this information, guys, revise as much question papers as possible before your exams. That can actually help you a lot. Okay, so that's what you had, guys, for Mason African motives. Till we meet again.